So that's the big deal. Find theta here. So I'm just going to do a force diagram. I think we also did one of our practice problems just like this.
Something similar.
So did doing those and going through those help prepare you for this? That was the idea. Did anyone find like it was any better going through this homework?
You need like a star.
Okay.
Give me something to go on.
Good. Okay, cool. All right, good. So this is, of course, T. This is mg. This is Fe right here. And so we have some of the forces in the x is 0. Some of the forces in the y is 0. So we have, if that's theta, we have T sine theta is equal to Fe, and we have T cos theta is equal to mg, so we get Fe over sine theta is equal to mg over cos theta.
And then solve?
Yeah, so then what I would do is I would say tan theta is equal to, whoops, Fe over mg, or theta is going to be equal to the inverse tangent of k q squared. Oh, just kidding. Oh no, I do need that. Yeah, that's right. I'm not kidding. So there.
Wait, why is it q squared?
Over r squared, because it's this one's effect on this one,
Oh. So
and then this is
that's the
mg.
part?
And of course, we have to remember that r is equal to L. Sorry, it's 2 times L sine. Oh, that sucks. Sucks rocks.
What?
Can't use it.
Yeah, I can't do that. I have to do this first. So let me go back, because Fe. Sorry, Fe is what? Since Ling's lost, he'll tell us what Fe is.
What?
What's Fe? What is the force pushing this to the right? Why are those two balls separated?
Why are they
Can you
separated?
read the
Oh.
problem?
Oh.
Do you have the problem in front of you?
No. What?
Everyone bring your books tomorrow.
Great. Oh yeah, we don't have class tomorrow. It doesn't matter.
Oh, but when we do have class on Thursday, bring your book.
Yeah, I know. On final.
Okay, so someone who has a question, can they tell us? Can they tell Ling what? So, well, I'll just tell you. These two spheres here have 100 microcoulombs of charge, or no, nanocoulombs, excuse me. Each one is 100 nanocoulombs of charge. Why are they hanging like this? Yes. So then, what is the force? What is the equation for the force of that repulsion? Don't forget, it's 2. It's not E.
Oh.
E is kq over r squared, but it's k q1
Oh.
q2 over r squared. And do you see that this is r, right? And r is equal to 2L sine theta, yes?
So we set them equal to each other?
Well, sort of. So then we have to say, so now I'm going to go ahead and fill this out. This says k, this is just q squared over r squared. So it's going to, oh my gosh, that's fugly.
Do we even have FE? Wait, Mr. McClure?
Ah! Okay, excellent. That's pretty slick bastards. All right.
I was trying to do it. I was like, this is all back to
Okay, so we get this. I'm just going to go ahead and do this nightmare out because this is hilarious. So I get k q squared over 4L squared sine cubed theta equals mg over cosine theta.
Why do you have sine?
No, yeah, it's on the bottom, right?
Yeah, but why is this?
Because this plugged in there becomes this.
Oh, okay. Oh, great. That's okay.
Right? Isn't it? If you multiply sine theta times sine squared theta, you get sine cubed theta?
Yeah,
Okay.
you do.
Now, we are completely and totally screwed, yes?
Yeah.
Unless you look at the hint. What did the hint say? It said theta is small. What can you say for very small angles?
Our sine theta is almost the same as r.
Yeah. So then what does that allow us to say that sine is?
Equal to r.
So then, because like, if we look at this triangle, right, this is R and that's L. So then the sine of theta, we can say is, or if we just go ahead and say it's R, if that's R over L and then plug that in for here,
That makes it use as r.
then we find, yeah, so,
So it's r cubed?
wait a minute, this was so clear 30 seconds ago.
It's still pretty so bad. These me how like two unknown variables. And then just sign on
Wait, okay, the small angle approximation lets us say, so the cosine of theta is like L, right? And then the sine of theta based on the small angle approximation. Oh, come on. Why is this not? This works. This works. I know sine theta is like theta, right?
And then if it's for cosine, it's the smaller it is, the closer it is to 1. That's it.
Well, if you say that's theta, then sine becomes, wow, could that be? Nah. Because then that would be, this is theta cubed and that's 1. So then just solve it for theta by taking the cube root of that. All right, let me go ahead and do something different here. I'm going to,
look at the answers.
Use that
Yeah.
super geometry.
yeah, I don't know. I mean, that is the way that it's supposed to be done out. I'm just having a brain fart about how to do it.
So organized.
What was this? 50 what?
3. No, 9.
9? Dude, so sad. Like, Mr. Salas posted like some problems over break. It got like 2,000 views. I probably posted like 2,000 problems and I got like 3 views. It's like the guy is better than me in everything. It's so depressing.
Wait, a calculus video?
I don't know. I mean, I think it's for it was for algebra or something like that.
That's so funny.
Because we learned in class.
That's not helpful. It's a little bit helpful. Okay, so we did this. Now, where is that approximation? What does that help us do? Okay, wait, look. Okay, here's the thing right here. So it says, we pretty much got this, right?
Yeah.
This is pretty much what we got. And it says for small angles, tan theta is sine theta. So they said sine theta is equal to that. So magically that's true.
Wait, how's that true?
Well, so they're saying that this is sine cubed theta. So then how do you get? So would you take the cube root of this and then take the inverse tangent of that?
They said a tangent, tangent theta is equal to sine theta, so I think so either.
So this is actually kind of funny, and this is good for you to learn this now because this happens in college all the time. Like you'll buy the solutions manual or whatever, and then you'll go through it, and then you'll see, oh, they didn't do it here. They're a little bit nicer. The classic thing was the word clearly, or therefore. So it's like, blah, 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 and I'm like, okay, I got it, and clearly, and you're like, what the fuck? I don't get clearly. Clearly, it's not clear. And so, do you see why, through this substitution, this becomes this?
What?
So, okay. Try this. Somebody take the cube root of this.
Why would we? You don't want to be.
I think that's why. Yeah, that's why.
All
All right. Do you see that? So what they say is that the approximation says that tan theta is sine theta. So then that means we get sine cube theta is equal to this gibberish. So then you take the cube root of this, and that means sine theta is equal to this. This is the cube root of that. And then you take the inverse sine of that, and you get your answer of 4.42 degrees.
Wait.
Whatever. Anyways.
Oh my god, that is. How do you know that tangent data is equal to sine data though? How do you know?
Because the angle's super small, so we can
Yeah, I know the angle's super small, but.
How do you know what? Sorry?
Okay, so why is tangent data equal to?
Oh,
sine?
that's the small angle approximation. That's what it means. The small angle approximation lets you do a bunch of things. I just used the wrong one. That's why I got stuck. The one I should have used was tan theta is approximately equal to sine theta.
Is there mathematical proof that shows that?
Yeah. It's just because, like, if you look, watch, like, do like the tangent of like 1 degree.
The tangent of 1 degree. Small.
Now do the tangent of, the sine of 1 degree.
Oh, this is.
Do you see how they're very, very close?
Uh-huh.
Yeah, that's the small angle approximation.
Oh, okay.
Are we supposed to know that?
Yeah, so, well, your book mentions this actually, and actually I thought I'd used this in a lecture before. Didn't Jack use this in a lecture? The pendulum. We talked about the pendulum. Yeah. In the pendulum, last semester in the pendulum.
Yay!
Okay, so the idea here is we haven't done anything wrong. I'm gonna cheat here. And David, what did you say the small angle theory did for you for cosine?
Now all I see is you bring the cosine over and
Okay, look, for a very small angle, what does cosine approach?
0.
1, right?
Oh, it's just 1.
Right, because as this gets closer and closer and closer,
Uh-huh.
then this side is closer to that side, true?
Uh-huh.
So for small angles, now hang with me here, please, and we'll see this. Cosine is like 1, true? So then that becomes 1. Now solve that.
Oh, it's the same thing.
Yeah, we did it.
Wait.
And all because of David. Although he couldn't remember what he said 10 minutes ago.
Oh.
Right? So we're gonna get sine cube theta is equal to kq squared over mg 4l squared. And just plug all that stuff in, take the cube root of both sides, inverse sine, and boom, get your answer.
It's the exact
And the answer was like 4.4 degrees. Yeah, you'll get the exact same answer.
Oh.
Because, see, this is exactly what we got on the other thing. Because on the other one, we left this extra sine and this cosine, we left it as tangent.
Uh-huh.
And then we set tangent equal to sine, which gave us a sine cube.
Uh-huh.
And then we did the same thing.
But the cosine one was easier.
Yeah, there you go. Whatever you like. There's also another way to do, because the other thing about the sine small angle theorem is something about that, but whatever. Okay, any questions on that part? So the hint was very important. No hint, no joy.
Yay.